This week we'll wrap up the complex map that we've been working on for the last few weeks by calculating some categories or conditions and coloring the sky cover symbol based upon those. Welcome to another MetPy Monday. Hello, I'm John Lehman, a software engineer for Unidata. This week, we're going to go ahead and calculate what the flight condition is, or the closest thing that we can calculate currently, at our airport sites and color code the cloud cover symbols based upon that. So I'm going to start out with the notebook that we had last week. Again, if you need to catch up, check out the last couple MetPy Mondays where we talk about getting RTMA, METAR, satellite, and then doing some calculations like equivalent potential temperature. So I'm just going to run through this notebook so that we get the most recent information. But I'm going to stop before plot. And in command mode, I'm going to use the A key to add a few cells. All right, so our notebook has successfully run up to there. I'm going to put a markdown cell in here, and we'll list the conditions. So low IFR is going to be a less than 500-foot ceiling, where ceilings are defined as either broken or overcast, and less than 1 mile visibility. IFR is going to be 500 to 1,000 foot ceilings and 1 to 3 miles. Minimal VFR is going to be 1,000 to 3,000 feet and 3 to 5 miles. And finally, VFR, visual flight rules, is going to be greater than 3,000 foot ceilings with greater than 5 miles of visibility. Now, unfortunately, the METAR parser currently doesn't actually pull out visibility, so we're not really going to be able to calculate the flight condition. We're going to be able to just use the ceiling height and take a guess at it, and that's what we're going to color the cloud cover symbol based on. But this is not a fully featured flight condition calculator, and of course shouldn't be used as such yet. Now we are going to be adding that into MetPy, so hopefully visibility and a few other fields like some of the remarks will be coming through relatively soon. From metpy.units, we're going to import the units registry. Believe it or not, we haven't had to do that until now. And I'm going to make a function that classifies what flight category we're in. So we're going to call it def find category. It's going to take the cloud type and the cloud level. Again, since we don't have visibility available, we're not going to factor it into this calculation. Calculate the flight category at a station. And I'm going to wrap this in a try except. You'll see why here in a little bit. So if our cloud type is equal to clear, bitwise or our cloud type is equal to SKC for sky clear, then we're going to return the flight category as VFR. If there is no ceiling, then it doesn't matter. Now again, we could go ahead and do some more checking of if there's a ceiling and it's below 3,000, make this a more complicated statement. But you'll see we're going to use this logical flow of if, elif, and else to make these statements as simple as we possibly can. And of course, remember that we're enclosing these in parentheses because of order of operations. We want to do these first and then take that bitwise or a bitwise and. Next, it's going to be an elif. The cloud level is less than 500 units.feet Then we're going to return low IFR. LF cloud level, we got a typo there, 500 feet. If it's less than 1,000 units.feet, then we're going to return IFR. Cloud level below 3,000. Return MVFR. LF cloud level greater than 3,000. Return VFR. And then else, we're going to return unknown. So it could be a malfunctioning instrument or something else. Now I've also found that there are some cases where the METAR parser can't parse a poorly formatted METAR string. And sometimes we actually will get a cloud level that's a string and something very mixed. It doesn't make sense. And that will cause this to error. So we're going to use an exception. And if there's any exception, we're going to return unknown. But catching all exceptions is not good practice. So we're going to limit it to a type error. That's the most common one that I've seen. And you can see I'd made these statements relatively simple because the order I did them in. So by going from 500 to 1,000 to 3,000 and so on, we're able to have a relatively simple progression here. Now I'm going to make an empty categories list. Of course, you could do this as a list comprehension or something a little more compact. But for cloud type, cloud level, in zip, our surface data that we had last week, the low cloud type, surface data, low cloud level. So we're going to go through those stepwise, going through each element, assign it to cloud type and cloud level. Categories.append, our find category function, the cloud type, the cloud level. And of course, again, you're going to want to potentially make this more robust. Before you would operationalize anything like this, of course, you do a lot of different checking. You write a lot of test cases to make sure that you're capturing what you think you're capturing. And finally, we're going to make it an array so that we can do these Boolean operations easily that we can't do to a list. All right, so we see we've got a mix here in our categories array. So now it's time to plot. So let's go down here to our METARs. Now, unfortunately, we can't color the cloud coverage based on some variable. The way that the station plot works, they're all going to be the same color. So what we're going to need to do is call station plot for each different category. Now you could copy and paste a lot of code, or you could write a loop. So for category and color in zip, and I'm just going to type my lists right in here. Low IFR, IFR, MVFR, VFR, and unknown. So those are my categories. I'm going to line wrap here. And now the color that I want to plot each category in. Magenta, tab red, tab blue, tab green, and if we don't know what it is, we're just going to leave it as black. All right, so now we're in our for loop. The first thing we need to do is create a mask. We already have our surface data mask, which we want to keep. That's to decimate our stations. And what we're going to do this time is the bitwise AND operation with our categories array And we're going to do a Boolean comparison to the category that we're currently looking at. So we'll have two Booleans, and we'll do the bitwise AND of them. Now we're going to indent all of the station plotting. We're going to change every surface data mask instance to just be mask. All right. And now we should be able to run this cell and get our plot. Again, remember, because of the satellite data, it's going to take a little while to plot. And occasionally you're going to have something like this where we can't actually go get that data. Our connection is probably just expired here. So I'm going to go ahead and restart and run all the cells in my notebook, and we'll wait for this map to generate. And here we go. So we've got our map, and the cloud cover symbols are colored based on the estimated flight condition. So we've got temperature, satellite, theta E, and surface obs all on one map. I hope that you found this series on making a complicated real-world weather map useful. And next week, we'll get back to looking at some of our other favorite plots and different things you can do with MetPy. I'll see you on next week's MetPy Monday.